Desert turns into fertile land. The August sun is particularly dazzling. Starting from the urban area of Wuhai, drive across the Yellow River pontoon, heading west, through dilapidated villages and rolling sand dunes, and reach the end of the sand crossing highway. Suddenly, an oasis appears in the yellow sand. The golden sunflowers, lush green grass, and numerous fruits of eggplant and chili peppers hanging on the branches are like a large translational sprinkler with a long steel dragon. A modern farm beyond our reach comes into sight and is surprising. At 39 degrees 36-32 foot north latitude and 106 degrees 39 minutes 02 east longitude, Yulingbu Pilot Research Base 4 desertification has no name on the Baidu map, but its ecological miracle of turning deserts into fertile fields in a few years has stunned the entire world. Science and technology have changed the world, and the vitality in the desert is the most beautiful medal for Yi Zhijian, the founder of this green myth and the 2021 Most Beautiful Scientist, Vice President of Chongqing Jiaotong University, and his research team. Create a new path to embark on an adventure in cross-border desertification control. Land desertification control has always been a world-class problem. According to data, currently, the area of deserts and other arid areas threatened by global desertification has reached 41.3% of the Earth's land area. And it is expanding at a speed of 50,000 to 70,000 square kilometers per year. China has worked hard to control desertification for decades, but the effect is also limited. The area of desertified land has reached 1.73 by 106 square kilometers, accounting for 18.03% of the total land area, and an additional 3.1 times the 105 square kilometers of land show a clear trend of desertification. There are three main types of current desert control methods: engineering sand control, chemical sand control, and plant sand control. Engineering sand control is to prevent the movement of sand by establishing obstacles such as grass-checkered sand barriers and sand fences. Chemical sand control is to solidify the surface layer of sand by spraying emulsified asphalt or polymer latex onto the surface of the desert. Plant desertification control refers to the restoration of deserts by planting sandy plants. These desertification control methods have advantages and disadvantages, and have certain effects on desertification control, but they are difficult to promote on a large scale. Yi Zhijian, a famous mechanical expert in China, has long been engaged in basic theory and application research of mechanics. In 2009, during the process of studying the mechanics of granular materials, he accidentally discovered that the transition of granular materials from discrete state to rheological state and solid state relies on a universal constraint relationship. Soil is in a rheological state when wet, and in a solid state when dry, and can stably transition between these two states. This mechanical property of soil endows it with two major ecological mechanical properties, namely self-repairing and self-regulation, enabling it to maintain a thriving ecological cycle and become an ideal carrier for plants. The difference between sand and soil is that sand is usually in a discrete state, and the constraints between its particles are contact constraints. Through further research, Yi Zhijian found that when water-soluble substances with appropriate viscosity are added to the sand particles and mixed evenly, an omnidirectional comprehensive ODI constraint with universal and recoverable properties will be formed between the sand particles, and the sand will also transition from a discrete state to a rheological state, which is similar to wet soil. When the water in the added water-soluble material evaporates, the ODI constraint will be transformed into a consolidation constraint, and the sand will be transformed into a solid state, which is similar to dry soil. Soiled sand has the mechanical properties of natural soil and can stably transition between rheological and solid states, thereby gaining the same ability to store water, nutrients, and air as soil, making it an ideal carrier for plant growth. Based on this theory, Yi Zhijian pioneered the technological path of soil desertification in deserts. By establishing a link between soil mechanical properties and ecological properties, he explained the mystery of soil's ability to thrive from a mechanical perspective. The function of soil is to serve as a carrier for plant growth, and the soiling properties of sand can be experimentally verified by planting plants. Subsequently, to verify their research, Yi Zhijian's team opened a 3-year planting experiment in the laboratory of Chongqing Jiaotong University, where their figures can be seen everywhere from balconies, roofs, and outdoor planting areas. In order to simulate the infiltration conditions of the desert sand layer, they successively laid a gravel layer 20 to 30 centimeters thick, 15 to 25 centimeters thick untreated ordinary river sand, and 10 to 20 centimeters thick, soil-modified, soil on the experimental ground. The rotation of various plants such as corn, sweet potatoes, and radishes is promising. Yi Zhijian's confidence doubled. Planting experiments have fully verified that soiled sand is an ideal carrier for plant growth, and its ecological and mechanical properties can be maintained for a long time. Strive unremittingly to stand at a new starting point of industrialization. The scientific essence of desertification is to enable the sand on the surface of a desert to acquire the mechanical properties and ecological properties of the soil. In principle, desertification is a reverse process of desertification, with the potential to realize human dreams of turning deserts into oases, improve the ecological environment in desert areas, and ultimately benefit mankind. As a scientific proposition, the feasibility of desertification must be tested through field practice in the desert. In 2016, Yi Zhijian led his team out of the laboratory and started a new round of fighting in the vast desert. From the beginning, Yi Zhijian set his goal on the most difficult desert to control. When selecting a site, he proposed 3 requirements: no grass grows, appropriate water resources should be available, don't let anyone interfere. Therefore, the Yulunbu Desert, where the sand is 3 feet deep and horses cannot walk, became their test ground. In 2016, 25 mu of desert was transformed into soil and successfully planted. In February 2017, preliminary survey of the 10,000 mu experimental site. In March, large machinery moved into the desert, and infrastructure such as reservoirs and highways were completed. In April, the research team entered the soiling construction phase of a 10,000 mu experimental site, laying mixed materials on thousands of acres of desert. In June, the 4th trial planting was successful. In 2018, the scientific research team conducted experiments and demonstrations simultaneously in Inner Mongolia, Xinjiang, Sichuan Rouergai, Xiamen Island, and other places. In 2019, the planting area in the Taklamakan Desert expanded to 20,000 mu. The current situation is that the team has successfully experimented in multiple places such as Yulunbu Desert, planting over 70 crops such as radishes, sorghum, panisetum, tomatoes, and eggplants. Among them, the yield of radishes per mu planted in Yulunbu Desert has reached over 13,000 kilograms, and the yield of sorghum per mu has reached 789 kilograms, both higher than the national average. As an original and breakthrough achievement of, from 0 to 1, mechanical sand control has been continuously questioned from theoretical proposal to practical verification. However, Yi Zhijian and his team have never wavered and are dedicated to proving themselves with practical results. It is precisely this powerful spiritual force and scientific philosophy that has led them to make significant breakthroughs in the field of scientific research. According to Yi Zhijian, compared to conventional desert control methods, desert soil technology has the characteristics of low cost, significant water saving, environmental protection and safety, and rapid promotion. Deserts that are close to water sources or have sufficient groundwater can achieve sand to soil. The cost of soil reclamation is no more than 5,000 yuan per mu, far lower than the tens of thousands of yuan that is often spent on soil reclamation in the mainland. Moreover, once added for a long time, the root system of the plant that grows decays, and then becomes a new constraint, forming a virtuous cycle of ecology. Facts speak louder than words, and the results of the experiment forcefully break the skepticism. On September 18, 2021, the evaluation committee organized by the China Association for the Promotion of Industry, University, and Research Cooperation held an evaluation meeting on the results of the demonstration project of key technologies and ecological control of desertification in Wuhai City, Inner Mongolia. After more than 3 hours of questioning and discussion, the experts of the evaluation committee unanimously agreed that desertification is an original and breakthrough achievement with significant economic, social, and ecological benefits. It is of great significance to national ecological security, food security, and other aspects, providing a reference for global desert governance, and achieving international leading levels. In the same year, Yi Zhijian was also awarded the honorary title of Most Beautiful Scientific and Technological Worker in 2021 by the Propaganda Department of the Central Committee, the Chinese Association for Science and Technology, the Ministry of Science and Technology, the Chinese Academy of Sciences, the Chinese Academy of Engineering, and the Administration of Science, Technology, and Industry for National Defense. Support and affirmation followed. To cooperate with Chongqing Jiaotong University to build a joint laboratory for desert ecological reconstruction, establish a large public research platform to support the research institute, and build a new research institute and discipline for desert ecological mechanics. Han Guiqing, academician of the International Academy of Agricultural Education and Sciences, and the first chairman of the International Black Earth Alliance of the Food and Agriculture Organization of the United Nations, also stated that as an agricultural expert, he should fully support this project. Industrialized application is the foothold of scientific research development. In 2022, Yi Zhijian and his team stood at a new starting point towards industrialization. After 6 years of pilot testing, the technology has become relatively mature. On the basis of the early exploration of the industrialization of the Convention of the Sand, this year a project will officially enter industrialization, not only to prevent and control desertification and restore ecology, but also to bring economic benefits to the local area. Yi Zhijian introduced that currently, The newly signed project covers a total of 130,000 mu of deserts and Gobi in Inner Mongolia and Xinjiang. This year, the team plans to renovate about 3,000 mu of deserts and Gobi in the Kabuki Desert of Hangjin Banner, Erdo City, Inner Mongolia, and Ruoqiang, Xinjiang, to carry out industrial demonstration-based construction.